Good morning, grade 6. Today we are going to talk about electric charge and static electricity. Yesterday we started talking about the electric charge. We said that each atom has positive charge and negative charge. We take an example of electric charge. If they are the same, they will repel, while if they are opposite, they will attract. If they are the same, they will repel, and if they are opposite, they will attract. This is the electric charge. We have two types of the electric charge, and each electric charge has its own electric field, the area around it, the regions around a charged object. We call this the electric field. You have to be close to the electric charge so you will feel the force that exert because of this charge. If it's far, it will not attract, neither repel the other object. They have to be in the electric field. Electric field is the region around each electric charge. Then yesterday we started talking about how to build up and charge. Build up charge. How to build up a charge? We call it static electricity. Static electricity, static stay, is the electric charge that stay on the object. In the normal state, each object has equal number of positive and negative. We call this neutral. Neutral or equal, neutral. But sometimes they build up an electric charge. Some electric charge come on these objects. How? Today we are going to discuss this. We have 4 ways. Darling, mute your mic. We have 4 ways to charge objects. As a conservation of charge, the charge, Jude, please, darling, mute your mic. So, the charge neither destroyed nor created. So, the charge neither created nor destroyed. Conservation. If you have electric charge, there's electric charge. It will not destroy or create. How come some objects became electric? They have static electricity. They have 4 ways. The first one, to rub, like yesterday. Rubbing or frictions, like when you rub your 2 hands. When you rub your legs, your feet with the carpet. So the first way is frictions. Yesterday I show you that when I bring the balloon near to the sweater after frictions, so that your feet will gain a negative charge. Take it from the curtain. So how this static electricity will build? One of them lose, while the other will gain. Lose and gain by frictions. If one lose electrons, it became positive. The one who gain electron become negative. This is the first way. What about the second way? The second way, it's by conduction. Conduction. It's by direct contact. How come this one? It's not rubbing. Look at this. There is a positive ball. Positive ball. It's already have a charge. Positive ball.
Positive.
Okay? This is all of them must be positive.
Okay.
So this is positive ball. Now, if a girl, she is normal, she is neutral, have positive and negative, okay? Now, if this girl just come close to this ball is charged positive, okay? Now, what happened to this girl? This girl just touch. She doesn't frictions, doesn't rub. There's no frictions, only touch. She touched the ball. Now, all the negative in her hand and her body just come close to the positive. They attract. The negative attract. The negative is the movement charge. Okay? The negative just move to her, to the ball. If the negative move to the ball, what rest? Positive. So her hair will do like this because they are charged by conductions, by touch, conductions. Again, the first way, by frictions, you have to wrap two things together. Let's highlight. The first way, when you wrap together two things together, one will lose and one will gain. So the object that lose electron become positive, and the one that gain become negative. One is positive and one is negative. So, and here the object that gain electron become negative. We call this one
Teacher, wait a minute.
frictions.
Friction.
Frictions.
Friction.
Frictions
Wait
or
1
wrapping.
minute.
Okay. Frictions and wrapping, this one mean to
Okay.
wrap two objects together. I forgot to highlight with you here the conservations of charge. The charge are neither created nor destroyed. They are just turned from object to another object. One object lose electrons, another object must pick up this. So the electrons are not flying, are not destroyed, only just transfer from object to another object. So the first way is by frictions, by wrapping two objects together. The second one is by conductions. Conductions. What is the conductions mean? Conductions by direct contact. Direct contact. Direct contact without wrappings. Only if you touch, but it must be object that charged. When a charged object touch another object. So we have to start with charged object. So anything that come close to, it will gain another charge. This is the first. So I'm talking about the frictions, number one. Number two, conductions. Let's see what is number three. Number three, charging by inductions. Inductions. Let's see inductions. Now, in the inductions is the example of the comb and the paper clip that I told you yesterday about that. Charging by induction. So, electrons can react to their electric field of a charged object without touching the object itself. Without touching, it just react by itself. Even the paper has positive and negative, they are neutral. And here the comb has negative. They will attract, you just come to the electric field, So here I want by the inductions, when the electrons react to the electric field, just come close to and it will work. Okay, so inductions is just to come close in the electric field and it will charge. Okay, let's see this video.
Okay.
They said that the charge transfer by, if you rub two objects together by frictions, like you rub here, rub the balloon with a sweater or something. Now the hair, if they rub a piece of rug or something with clothes with the balloon, now the balloon will gain the positive charge. And yeah, this is what, look what will happen when I bring the balloon close to the hair. When just come close to the hair, we call this one by frictions. What about conductions? Conductions, we say I have to start with things that charge. I have this charge. When they come close to each other. So in conductions, they have to touch in direct contact, but I have to start. Look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. While here, 1, 2, 3, 4, 5, 6. This is 6 electrons, and this is 10. They conduct by only they just touch. So this one, conductions. While the third way, how the objects will, I have here it's positive and here it's positive and neutral. What do you think happen when they come close to each other? Look what will happen if this is positive and this is neutral. Look what will happen when they come close to each other. I want to show you here when I bring them close to each other. Sorry, the net is very weak. So conduction, I have to start with object that charged already. While the third one is the inductions. Inductions, I will try this later. Okay, induction, I have here neutral conductor. Neutral, it's positive and negative. Neutral conductors. If I brought something charged, what happened? It will not jump, but only it will be here positive. It's still neutral. This is so when I bring things near to the electric field, so they will start to get the electric charge. Let's open our book, page 163. Now, we highlight this. I want to see this one, yes. Inductions, it react when it came to the electric field. Now, what about polarization? Now, polarization, the electrons react to electric field, resulting in individual atoms having charge and that are attracted to charged objects. This is called polarizations. charge don't transfer between objects in polarization. They still polarization mean the electric charge still in the same object, but some of them come to the right and the other to the left. This is polarization. The same object have the same charge, but they are arranged. Some of them go to the, if you remember yesterday, the wall, the electric charge from the wall doesn't transfer. They still in the wall, but some of them come close to the balloon, and while some of them they repel, they are pushed away from the balloon. Polarizations. So in the polarization here, the electrons react. Here they react, but that are the attracted charge. We say that the atoms having charge, the same atoms. So the charge don't transfer between objects in the polarization. Okay? They have the same overcharge, but only they are just moving away. Some parts become positive and the other part become negative, but they are not transfer. Like this paper clips. The paper clips just come, the positive come close to the comb and the negative far away, but they didn't transfer. Okay? So induction and polarization are the same because the electric charge don't jump, don't go, don't transfer. They stay in the same material. You have 3 positive, 3 negative, you still have 3 positive, 3 negative, but the positive will be in the right, all the positive become close, and the negative are the opposite side. Here, the opposite side. Let's see. Sometimes the statics, we said them. The electric charge, they stay on the objects, they jump. Like what? Like lightning. The example, static, we say static electricity, they stay. Static, from they stay in their place. Build up on an object. Build up on an object. They stay in this area. They didn't move. But sometimes this charge are moved from object to other object. The loss of static electricity. To lose this static, they are not stay. The loss of static electricity, we call this, they are transferred from object to another object. We call this one discharge. To lose the static electricity. Actually, we call this jump. They make as a spark. They produce spark. We can hear the spark and we can feel the spark. Again, static electricity are the electric charge that build up on an object. But sometimes this electric charge are jump, transfer from object to another object. We call this one static discharge. This, the prefix this, mean the opposite of charge, losing this charge, discharge. Now this one produce a spark. I want just to give you some examples of this one. If you just gluing, sometimes you feel the sparks when you touch the doorknob. You feel the tiny sparks may have felt or seen when a near doorknob is an example of static. You just touch a doorknob, you can feel it. Also, if you just push a cart for a long time, also you can feel this one. Let me help you with this example. The common example and the easiest example for us is the lightning. Lightning.
But teacher,
Yes.
I don't understand this part, teacher. Now. Yes,
Discharge.
yes. So
Okay. Okay. I will explain it now. Now, as you know, a cloud is made of water vapor. The water vapor condenses in the clouds, right? Now, the cloud has a lot of droplets. These droplets rub or frictions, rub or frictions. They rub each other. That's why some of them become positive while others become negative. This will be negative, negative at the bottom of the cloud, while positive and positive,
and was
and this is positive. They are equal, but some of them
yes.
become negative and while others are become positive. Now, by fractions, because they fraction each other. Now, the ground's first has a positive charge. I will make it with green. I want the screen to become smaller so all of them you can see them now. No, like this. Yes. So the ground is positive, positive, and this is positive. And the droplets, the water, the small drops of water in the air, in the clouds, this become charged by frictions because they touch each other. This is all of them. The bottom clouds are negative, while at the top is positive, and the ground is positive also. Now, if you can see, I have here different electric charge. Sorry, this is negative. And this is negative. I have negative, and here I have positive. What do you think happens if I have different electric charge? They will attract. The negative will be attracted to the positive and come down. They form the lightning. So the lightning will form, and you will feel, and you can see it here. So the lightning is one of the electric discharge, is the example. Even you just rub your feet with the carpet now, then touch knife, any metal object, knife or the doorknob, then you will feel the spark, and sometimes you will hear the spark also. This is electric discharge. Electric discharge.